Hey guys, in this video we will talk about slanted platform. But before starting that, I would like to teach you guys about some basics about angle between two vectors. It is not a mathematics concept. It is just a unity concept. Means it is a mathematics concept, but Unity already had given you a library, so you can use it. So let's see that, then we will see about slanted platform. So here I have two game object. This game object is at 0 0 and one more game object, this is also at 0 0. Now if you see the right vector of vector A, it is pointing in this direction, that is it is like this. Even vector B, it is pointing in this direction. Now if you want to find the angle between two vector, in mathematics there is something called you can find the angle between two vector. So in this case for vector A and vector B, if you want to find the angle between the right vector, that is if you want to find angle between vector A right vector and vector B right vector, you can use unity inbuilt function called vector 3 dot angle. Since we are dealing with vector 3 xyz, we use this. If you want to find the angle between vector 2, then unity gives that also, vector 2 dot angle. We will be using vector 2 dot angle, but since in this scenario we assume that z axis is always 0, so even if you use vector 3 dot angle, z won't be considered into the computation, because in 2D you can rotate like this. That's it. Means if you see, right vector is like this. Now if I rotate, it will be like this. So you will not be able to rotate in another way. That is, only one rotation is possible, either clockwise or anti-clockwise, and that too in 2D you will be rotating around z axis. So when I say z axis, I already told you in previous tutorial, this is a z axis. Around this axis we are going to rotate. So if I say, if I rotate this, if I rotate this clockwise, it will be like this. If I rotate this anti-clockwise, this blue vector, if I rotate anti-clockwise, if I rotate anti-clockwise, then you see this right vector is coming like this. So in 2D only z axis rotation is allowed. So now vector A right axis is like this, and vector B right axis is like this. Now if I find angle between these two vector, you are getting 37.428. So if I make this vector A right vector like this, 90°, so the angle between this vector and this vector is 90°. Likewise, if I keep rotating a vector, see the angle differs. So this vector and this vector, so the angle between them is 124, and it might go till 180°. See, after 180°, that is if it goes above 180°, it will again reset it. It will go again less than 180°, meaning angle of rotation, you can measure angle between two vector and its minimum value will be 0, maximum value will be 180. So this is how you will compute an angle between two vector, and unity already gives you a function vector 3 dot angle, where you give a first vector. Here I am giving transform dot right, and the second vector vector b dot transform right, and we check is this vector and this vector, what is the angle using this function, and at this point of time it returns 178. So there are quick tips with respect to angle. So if both the vectors are parallel, for example, if vector a right vector is like this and vector b is also like this, then both of them are parallel to each other, then on that case you will get 0. Now let me make this vector point like this, like in up axis. So I will make it 90 degree. So in this scenario, this vector and this vector angle is 90 degree. Similarly, if I make it 180 degree, this vector and this vector, the angle is 180 degree, because we will be using this concept in this tutorial. So that's the reason I created a separate script and I am showing you this feature. This is just like we do check with vector 3 dot angle. It will just compute the angle between two vectors. So we will use this feature to fulfill our functionality. Okay, so that's the reason I am teaching you how to measure an angle between two vectors. And the next thing is about normal. So for every object there is a normal. So for every surface there is a normal. So this is a mathematical term, but let me create one plane in 3D world. So this is a plane, it is like this. If somebody ask you what is the normal of this plane, you can tell this is the plane normal, that is this y-axis. See, it points like this. This is the normal of the plane, and if I rotate the plane like this in x-axis and in z-axis, see, now the plane is pointing in this direction. Plane is pointing, as normal is pointing outward direction. If this vector is pointing like this, it means the normal is pointing inward direction. So if it is in opposite direction, it is in. If it is pointing like this, it is out. So if I keep on rotating a plane, see, it normal also changes. So in this case it is world, not world up axis, it is object up axis. So this y-axis is the normal. Similarly, for each object there is a normal. Here you see in this Google image there is the sphere. So in sphere, if you want to find the normal of this point, assume there is a formula or anything, and at last if you query it for this point, the normal will be pointing in this direction. For this point it is like this, for this point it is like this point it is like this. So for this point, the if you see in sphere, the normal is coming like out like this. So in this case, this point plane will be something like this, like tilted. So let me put a sphere here. Okay, keep it at origin and let me move this plane over here. Let me reduce the size of the plane like this. So for this point, that is for this point on the sphere, if I scale it down more, you can see it clearly. So what happens is, this is a plane. Okay, so for the sphere, for this point, the plane normal is like this, and sorry, for this point, the normal is pointing in this direction, and if the normal is pointing in this direction, the plane for this normal will be like this. So this is the plane normal for this point on the sphere. So mathematically, if you draw normal for each point on the sphere, then the plane will be in different direction. So all you guys have to know is normal vector is a vector which is perpendicular to the uh, plane, that is which is perpendicular to the surface. So in this case, for sphere, if you see, this is the normal, and for this normal vector the plane is this is a plane, and if you take this angle between these two vector, you will get 90 degree. Okay, so this is the concept that you guys have to know, because we will be using a normal means we will be finding a normal of a surface. Okay, so in this case we are trying to find a normal vector of this surface, that is this point, right? This is a surface. For this we are trying to find a normal. So that's it. I hope I explained you guys clearly. So now let's go jump into our slanted platform. So I already created a script scene here, you can see, and this will be your final output. So you will be able to move up, down, and you will be able to jump. So everything happens. So we will see how this happens. I created a prefab called slanted platform. So this is a slanted platform. It is exactly like a normal platform. The only difference is ground. If you see the ground, it is tilted. So it is kind of a slope. In previous scenario, if you see this prefab, this ground, it's not tilted, it is a straight line. Only difference is that remaining things are exactly same. If you open it, see, they see the collider property, a collider object, you see green, this is for wall, and for yellow this is for wall, blue is for ceiling, red is for ground, and collider, sorry, layer and tag is set for all this game object, and we are doing line renderer. And I think accidentally I created this two game object which is not needed. Delete it. This is good. So now we have the slanted platform ready, exactly like the normal platform. With this information in the code, we have to check whether the player is hitting the slanted platform or not. If the player is hitting it, what we have to do, that we have to check it in the code. So let's click the player game object and open it. Open the prefab, and here I added one more game object called slanted platform race. Previously we had head race, foot race, side left race, and side right race. Now we added one more race called slanted platform race. This ray is used to check whether the player is hitting the slanted platform or not. If he is hitting, we will do some computation. So in a player script, if you open a player script, it's very simple. What I did here is I created an array of ray property, and I given a variable called slanted platform. So that variable will be exposed here in the inspector, and I am creating 7 array element. So for the first element I am giving ray as this is the ray object, and its forward vector is pointing in this direction, and its ray length is 0.3, and the color is this, because I want to make sure that these rays color are different comparing to the normal rays, so that we can differentiate it easily, so that differentiate it easily, that's what I mean to say. And now we have created 7 rays, like how we did for head and foot race, and for side left and side right race. So like this, here also I am creating 7 element. So first game object is ray 1 and ray 2, that is this one, ray 3, ray 4, ray 5, ray 6, ray 7. All this ray game object is exposed in this array, and we are giving the length 0.3 for all these rays, and the color is set to this. If you change the color, you can see how what happens. See, I'm changing the color for the second ray. It is blue, but I don't want that. Okay, so let me do Control Z, and I am saying the collision layer to check for is ground. So that's it. I have exposed all the rays for slanted platform in the inspector, and in on draw gizmos I check if slanted platform ray is not equal to null. I iterate it. I find whether the ray is not null. Then I draw a line. That is, then I draw a ray, and I am taking the ray color as this. So this is similar to how we draw head rays and foot rays and remaining rays, means whatever things we exposed here previously. For each of the ray we have created a visual uh, information. We created a visualization for all these rays in on draw gizmo. So now I am adding visualization for slanted platform rays also. Okay, now this is done. Now one more thing is, there is one function called slanted platform hit. So this function is similar to wall hit, and like any other function is grounded, similar to that only difference is instead of variable name is different. So here we take slanted platform rays, we cast a ray for we cast each of this ray and we check is any of this ray is hitting the ground. So inside this function we check if any of this ray hits the ground or not. If it hits, we return it. Similarly, like how we return it on is ground hit or in this function. So like in previous video tutorial we had checked for this function. Now we are adding this new function for slanted platform hit. So I think this function name is wrong, so let me make it slanted. Okay, it is not slated platform. Okay, so if any of the slanted platform rays hit, we return the hit info, and also we return this the ray that hits the ground. So that's what this function does. And now main thing happens in check for player ground position. Everything is same. We check is ground hit and this condition comes and everything is same. Only new lines that we added here for this tutorial is this line over here for this function. So we check whether the ground is hit or not. If the ground is hit, we check whether whether whatever ground that you hit, whether it's a slanted platform or it's a normal platform. Normal platform means it will be straight. Slanted means it will be kind of slope. So we check whether we are hitting a slanted platform. If it is hit, we check an angle between world up vector. So when I say world up vector, this is the world up vector. This will be always constant. So I created this empty game object here. When you say world up vector, this axis, right, this is called world up vector at any point of time. We check the world up vector and the hit normal. If the angle between both of them is greater than 0, it means we are hitting the slanted platform. Now you see how this angle between two vector, whatever we studied in this video tutorial at starting, this is getting useful now at this point of time. So that's the reason I taught you at initial stage. So what we do here is, if you open a slanted platform for a ground, this is a collider, and for this surface, if you ask what is the normal will be pointing in this direction. Let me put a game object and show you. This is the normal for this platform. So that's what Unity will give us. Okay, when you say hit info.normal, so when the slanted platform is hit, what we do here is we take this hit result and we assign it to slanted platform ray of I dot hit info. This will contain the hit, okay, and we return this slanted platform element itself, and from the element we retrieve the hit normal, and we check whether that hit normal and the world up vector angle is greater than 0, and we check one more condition on this frame whether user had given any input for movement or not. If the player is not had not if the player whoever is playing the game, if they had not given any input, then this will be false. So if it is false, this condition is satisfied, and if the normal and the vector up angle is greater than 0, then what I am doing is player velocity equal to 0, player rotation is also 0. This is the only calculation that we do here. So this is what happens. So if I run this slanted platform C, what happens is, now the character is like this. I am able to move up and down, okay, and if you put a breakpoint here, now we are hitting a slanted platform, okay, and we check whether the angle between normal and the world up vector is greater than 0. Yes. And in this frame, are we giving any movement input? No. So this is false. So this becomes true, and we set velocity to 0 and player rotation to 0. So this condition helps us to achieve this result. So you will be able to jump whenever I am moving. Whenever I am giving movement input, on that time this condition, this it won't break, because whenever I am giving input through keyboard or mouse for movement, this will be true and this condition won't be satisfied, and player will be moved right or left. So this happens. And one more thing that we need to do, this condition is well and good, but apart from this we need to do one more check for this to be 100% smooth, okay, that is in process jumping method. So in process jumping method, previously you should have seen only this if condition, there was no else condition. But before explaining this else condition, let me comment out this and let's see the output, how it looks like. You see, it is kind of jittering whenever the player is coming down. To avoid this, to avoid that jitter, we are going to enable this condition. So what happens is, in the process jumping, we check, are we touching the ground? If we are touching the ground, it will come to else condition, and it means we are touching a ground. Now we check whether we are touching the slanted platform or not. So if you are touching a slanted platform, then this won't be null, and we check this condition. This is similar to the one that you checked previously on check for player ground post function. Like same condition only we are checking up here, and if the normal and world vector is greater than 0 and if the movement key is not invoked, then set the velocity to 0. Else, it means if the movement key is invoked, means if the player had given any input on that frame, then on that case try to bring the player down, means try to pull the player down towards the ground, okay. So that's what this else condition will be set will do. And if you are not hitting the ground at all, if none of the ray hits the ground, this will be null. So we will try to pull our player down. So what happened is, since when we commented this condition earlier, Visually what happened is, let me tell you. For that I have to zoom in. Let me zoom in. So on this frame, assume on this frame the player is here and this ray is touching the ground, and this is a slanted platform, and assume on this frame itself the player had given a command that our character has to move left. So what will happen is, even though it is touching the ground, since the user had given input, the player velocity won't be set to null, meaning this condition, one second, check for, okay, so it will be hitting the slanted platform, but since the user is giving an input, this condition won't be satisfied and player will be moved a bit. So in the next frame player will be here. At this point of time also, if the user is holding the A key, it means he is saying we want to move our character left on this frame also, so it will move on this frame also. So what will happen is, in the next frame the character will be moved here. Again he is giving input and saying move left, so in the next frame it will be like this, and he does like this continuously. He is moving left, he is moving left, he is moving left, and at one point of time none of this ray will hit the ground. On that time, if you go to process jumping method, if you go to process jumping method, because after check for player ground post only this process jumping method is getting called. So on that frame none of the rays are hitting the ground, so this condition will be satisfied and player will be pulled down like this. So in between, from here to here, we moved minimum 3 times. So all these 3 times, uh, the the y value won't be changed. For example, from this frame to this frame till this frame, in this frame only it is not touching the ground. So what happens is, it will pull our player immediately down, so you feel like there is a jitter. So what happens is, whenever you move every frame, that is from here to here, we have to pull the player down. From here to here, if you move, we have to pull it down. But since we commented this condition, this else condition, what happened is, first frame you are here, second frame you are here, third frame you are here, fourth frame you are here, fifth frame you are here, sixth here, seventh. In the seventh frame you are just pulling the player down, because on that seventh frame this condition is getting satisfied, on ground is equal to false, so it immediately snaps to the ground. So in between 6 frames you are on the air like this, but even you are on the air, our ray was touching the ground, but on those frames you are not uh, snapping the player to the ground. Suddenly at the 7th frame when you do it, it jitters, and when you do this frequently, it feels like there is some jittery effect happening for the player. So our camera is shaking, as if it feels the effect is kind of spring or bouncing effect. Not bouncing effect, it feels like there is some kind of disturbance when it is moving on the slanted platform. So that's what happens if you comment this condition out. So if see, whenever I'm moving, there is this jitteriness, tuck tuck tuck, it jumps fast and comes to the ground. So when you enable this condition, what we do is, every frame we snap the player to the ground. okay, if the player is hitting the slanted platform. So in this case, first frame you are hitting a ground, so it will come to else condition. It will check, are we hitting a slanted platform or not. It will return true. And if you see here, this condition will be satisfied since we are, but this won't be satisfied because on this frame you are saying that I want to move the character left. So you had given the movement input. So even though this condition satisfies, this will fail and it will pull the player down. So it will be like this. In the next frame it will be something like this. Your player will be here and ray is touching. On that time also, when you give the left input, player will be pulled down, because since you had given an input, it will, this condition will satisfy, but you had given an input, so it will try to pull the player down and it will be here. And in the next frame, player will be here like this, player will be here like this. So all the frames it is snapping to the ground. That's what this else condition does. If you comment it out, you will get the jitteriness effect. The reason why we are doing it here also, we should have done only for check for player ground pose. There itself we should have done it. Even though we have done it here, we are doing again in process jumping method. That's because even though you alter the velocity here, after this only our process jumping function is getting called. So after you set the velocity 0 here, we again tweak the velocity in process jumping if you are not touching the ground. So that we don't want. So we should be sure, if you are touching the ground on each platform, after checking for the ground position, we should again check in process jumping, because this is the last function that executes in the order. So after this process jumping, here also you alter the player velocity. So here also we check if you are touching the ground, and if any of this condition satisfy. If you are not moving, it means if you are not giving any input, and if you are on slanted platform, make your player velocity 0. If you are giving a movement input, then on that case, if you are on the slanted platform, then try to pull the player down. So this condition, when you put this condition, things will work as expected and everything is smooth now. Okay, so we have seen how the slanted platform code works. For this, the code is very simple. Maybe 5 to 6 lines of code is only there, but the details, the amount of calculation and the optimization that it takes is the more important one. That's the reason I am explaining you guys very slowly, okay, so that you guys won't get confused. So now the slanted platform is done and normal platform is done. Now we can drag and drop this prefab at the level. We can add an exit icon, and once the player reaches the end of the level, it can load the next level. So now almost everything is done. In the next tutorial, I will create a sample levels and I will show you all the things. Means till now whatever we have learned, we will put all those pieces together and we will see how our sample level looks like. I hope you guys understood this tutorial. I will catch up all of you guys in the next video tutorial. Any complaints or something is not understood clearly, please put it in the comments below. I will see all of you guys soon. Bye. Thank you.